which is also equipped with a precision clock. From the time it takes the signal to get there, the board computer calculates the distance between the car and the satellite. If one of the clocks were even slightly inaccurate, it would put the driver miles off course. Precise determination of position requires calculating the distance between the car and 3 satellites. The car is located at the intersection of the 3 circles. And this is precisely what the electronic map indicates. The GPS satellites are flying around 20,000 kilometers above the Earth. Up there, the force of gravity is weaker than it is down on the ground. Accordingly, their atomic clocks go faster. As the satellites only move at 3.9 kilometers per second, the time expansion is relatively slight. The GPS takes account of the relativity effects exerted by altitude and speed to ensure that the clocks in the sky and on the ground are synchronized.
Nach 50 Metern links abbiegen.
So the fact that satellite navigation functions reliably is another feather in Einstein's cap. Science fiction series care little about such mundane earthly problems. If you're plotting your course through the limitless void, you have other aims in mind. Journeys back into the past are a special favorite.
Faszinierend.
Fenrich, was haben Sie da?
Ein erstaunliches Buch über das Leben meiner Vorfahren.
Was ist daran so ungewöhnlich?
Sie lebten in unglaublich primitiven Verhältnissen, mit Tieren zusammen. Es muss fürchterlich gerochen haben in diesen Gassen.
Es muss ewige Zeiten her sein. Sie wollen ja nicht etwa...
Ich habe schon alles vorbereitet. So kann man die doch nicht leben lassen.
Also gut. Auf den Schirm.
A time machine, whisking us back to the Middle Ages at the flick of a switch? An intriguing prospect. Using one's superior knowledge to get things sorted out, cure diseases, improve hygiene, combat the disgusting living conditions. But what if we fell victim to those epidemics instead of curing them and didn't survive the trip back into the past? Could we then turn back time again?
Traveling back through the centuries is the stock in trade of almost every science fiction movie. But there's a dilemma involved here. The dilemma is that if we traveled back into the past, we might destroy the basis for our existence in the present. In fact, not only might, we definitely would destroy it. Every change in the past would lead to a different future. We come from a specific future, and that specific future is the result of a specific past. If we change that past, then the future we come from will no longer exist. So in logical and physical terms, time travel is impossible.
We cannot put a broken glass together again. No one gets younger. Time cannot be reversed. However ingenious some science fiction stories may be, space travelers do have one thing in common with us. They do not have all the time in the world, and they want to get to their destination as fast as possible. Einstein appears to have left one loophole for people who are really in a hurry, a short cut through space-time. It goes by the charming name wormhole, and it's a trick for negotiating distances of galactic dimensions. Distances so vast that not even the super-fast warp drive is capable of bridging.
Helfen Sie uns! Die gravitätischen Störungen werden immer heftiger!
Commander Evans, wir tun, was wir können. Fenrich, sind die Warpkerne intakt?
Alles überprüft.
Maximum Warp.
Aye, Captain.
Wir müssen es schaffen. Ein Wurmloch ist die einzige Chance.
A wormhole contracts the huge distances out there in the universe. Commander Evans' starship could be saved at the last minute. Wormholes are just what the Doctor ordered for science fiction fans.
A wormhole is the perfect solution for all transport problems in the universe. It would make all the distances involved incredibly short. But to create a wormhole, you have to move masses. Mass bends space. That's general relativity theory. If we want to fly from point A to point B, and point B is a very long way away, say millions of light years, then you can move point B closer to point A by bending space. Then A and B are only as far apart as the palms of my hands. But to bend space, you have to move masses. You have to have huge masses that make it possible to bend space in that way. But to move masses, you have to have the energy it would take to do so. And it turns out that to produce a wormhole, you have to expend more energy than the universe provides. So shortcuts of this kind in the universe are unfortunately not a workable proposition.
Einstein was given an enthusiastic reception in New York in the early 1930s. He was acclaimed like a film star, though only very few people actually understood his theory of relativity.
Ich danke Ihnen herzlich für den wunderbaren Empfang, den Sie mir bereitet haben.
Like no other, Einstein has inspired the authors of Star Trek and other science fiction writers. He was the one who taught us to see space and time differently, in relative terms.